Right, so in these next couple of examples, we are going to use our permutation formula. Right, so as we're using our permutation formula, again, we're thinking about n factorial. So if we go back and look up here or up here, n factorial divided by n minus r factorial. All right, so you're among 8 people forming a skiing club. Collectively, you decide to put each person's name in a hat and to randomly select a president, a vice president, and a secretary. How many different arrangements or permutations of officers is possible? Right, so we are randomly selecting a president, a vice president, and secretary. So order matters, right? Which person is selected first for the vice president, first for the president, second for the vice president, third for the secretary matters. So this is indeed a permutation where order matters. Right? So we have a total of 8 people, and we are finding a permutation of 3 different offices. Right? So we're going to have 8 factorial over 8 minus 3 factorial. That's going to give us 8 factorial over 8 minus 3 factorial gives us 5 factorial. All right, so I'm going to go ahead and write this out the long way and show you all the canceling. Again, you don't necessarily have to do that if you don't want to. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then down here we have 5 times 4 times 3 times 2 times 1. Right. Everything's going to cancel except for the 8, the 7, and the 6. And we are left with 336 possible arrangements. Right, let's work through one more using our permutation formula. Right, the Prince George County Bicycle Club has 10 different routes members wish to travel exactly once, but they only have 6 specific dates for their trips. And how many ways can different routes be assigned to the dates scheduled for their trips? So we have 10 different routes and 6 different trips that are being chosen. Right, so we have 10 P6. So we're going to have 10 factorial over 10 minus 6 factorial, which is going to give us 10 factorial divided by 4 factorial. Right. So again, I'm going to write this out, expand my factorials. Excuse me. Right, so I'm going to have 10 times 9 times 8 times 7 times 6 times 5. And then instead of writing times 4 times 3 times 2 times 1, I'm just going to put 4 factorial. Right? So I'm just going to choose to leave that like that. So that way we can just kind of cancel out what we have in our denominator, that 4 factorial, without having to write every single digit out for each of these. Right? So those are going to cancel. We multiply what we have left, 10 times 9 times 8 times 7 times 6 times 5. And that's going to give us 151,200 possible arrangements. All right. So permutations, again, remember order matters. Permutations, our first number in our formula is the number of things that are being selected, the number of things that we are selecting from. First number is the number of things that we are selecting from. The second number, that R, is the number of different things that are being selected.